Alright, so let's have a go through this paper. Alright, so number one we know is correct. A. Number Number two we know is correct as well. C would be the answer for that question. Number three we know would be correct as well. Number three is correct. AR3D 10. Number four, which of the substances will, when burnt in oxygen, is highly exothermic? Aren't we just looking for the value? I think this question is an insult. The answer would be A, right? The one with the most negative value there. Alright. Looking at now, what is this diagram supposed to be telling us, right? Which of the following diagrams above is the sp3 orbital? So B would be the sp3 orbital. We have one small lobe and then one large lobe, right? So we would have a 33.33% what S characteristic, and the rest would be P characteristic. Lovely. Ammonia has the highest boiling point within all
Wait,
of these.
sir, what is A?
A would be a S orbital.
Alright.
B is sp3, 2 is P, and D would be either it is meant to show a general sp, or if it was a loop in the middle, then it would show one of the d orbitals. But all right, so number 7, ammonia with the highest boiling point, and obviously because it has the hydrogen bonding. Here now the element of magnesium exists in 3 isotopes. Here we know the relative atomic mass of magnesium is 24, right? 24.3 to be honest. It's not 24 flat. So some persons may see it and just put 24. No. 24.3. So when you work it out, you're gonna get 24.3 here, and we know the equation for that. Should be fine. Lovely. Which of the following observations is correct? So we have silver and we have copper. We're gonna have silver metal being deposited and the solution turns blue. Are we sure? Which one is more reactive, copper or silver? Which one is high on the reactivity series?
Silver is way at the bottom. Copper is above silver, so it's going to displace it.
Lovely, and then the solution will turn blue and silver will be deposited. Lovely. Number 10, which of the following groups of solids contain substances that all have? Alright, this is a repeat question. The answer would be B, graphite, iron, and sodium fluoride. Here, oh, this is a new question. Look how the question looks so nice. What that question looks so lovely. Which pathway in the diagram above describes the behavior of a beta particle? What is a beta particle? What's a beta particle?
It's a neutron, like an electron, kind of.
Kinda. You sound unsure, and I don't like when people are
The
unsure.
beta particle is a neutron that splits to give you a proton and an electron, that's all.
So they're high speed electrons, right? Or if it's positive, it would be a positron, right? I think that this level we only use the high speed electrons, right? So therefore, it would actually deflect further to the positive electrode, right? This would be the best answer. The lines of the spectrum become closer or converge at the shorter
Wait, you can go back
wavelength.
over there?
The electron, since it's gonna have a negative charge, it's gonna be deflected more
Mr.
by the.
Scott?
Okay, so since it has a higher negative charge, it's gonna be deflected more to the positive cathode, right? Um, More so than everything else, right? Because of its size as well, its weight. Its weight is fundamentally, theoretically, relatively zero, right? So it's gonna be deflected way more to the positive cathode than in any other scenario. So it's gonna be the most deflected. All right. The lines in the spectrum becomes closer, they converge at the shorter wavelength end of the spectrum lines, because difference in energy levels successive levels become smaller, so they decrease. So D is the best answer here, right? For number 13, we're looking at this equation here. The volume of a 0.005 molar of acidified potassium permanganate solution that is required to oxidize 20 cubic centimeters of 0.0025 moles of oxidate solution is, right? We're looking at that. So what we is it? I hope you guys notice. Do you guys notice this? It looks like a similar equation that they asked us to balance in the past, but instead of balancing, now they're asking us to find the volume required to neutralize. So what you need to do is combine the equations and then use more ratios. Not so.
Yeah, but you have to multiply first.
Well, when we combine them, that's how we're going to combine them. We need to cancel out. We're gonna times the first one by what 2, and the second one by what 5. Right, get both of them to 10, and then we cancel out and then move on where we're going from there.
5. Mm.
Lovely. All right. So when you do that now, times that by this is what 2. Oh, okay. That is not an x. Okay. Times that by 2, and then times this by 5. We're going to get 10. Right. So we're looking at acetyl potassium permanganate. So we're looking at permanganate, and we're looking at oxalates specifically, right? So permanganate would be 2 and oxalate would be 5, right? So if the volume required oxides is 20, what are we going to do to the 20? What's happening here? So we have X used to oxidize 20 of this, right? So what do we do? 5 divided by 2, how much? 2.5. What's happening here, guys? The answer is 20 divided by 2.5, which is 8. Ready to move on it? Mm-mm-mm-mm. Is everyone here? Hello? Everyone following?
Yeah, 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 yeah.
Alright, let's move on to the next question. Look at this paper is nice. I'm almost jealous. Which of the following diagrams best represents the enemy, not the enemy, the energy changes, right, for an exothermic reaction that proceeds in 2 stages? So the answer here would most suitably this. Okay, so it really doesn't matter, right? You see, the 2 stages thing is probably there to confuse you, right? This is going to be wrong, that must be wrong, and this must most definitely be wrong. C is the only suitable answer. C is the only suitable answer here. All right. When the emission spectrum of hydrogen, well, in the emission spectrum of hydrogen, hold on, what's happening? A possible electron transition responsible for a line visible in the Lyman series is one from the quantum level of n equals 70 to 2, right? One is Lyman, two is Balmer, three is Passion, and going up. So one is Lyman, that's lovely. Right, this is a repeat question to determine the KSP of the calcium hydroxide. This is a repeat question, right? Since there's gonna be one calcium and hydroxide is gonna be two hydroxides, we're gonna have the calcium regularly and hydroxide times power of stoichiometric coefficient.
One.
Lovely. All right. What is the pH of 2 moles, right, of that? So we're going to basically be looking at what is pH, a negative log of what? The answer is going to be D. Right? Right? So a negative log of 0.02 would be 1.69. The results of 4 experiments are presented here. Right, what we're looking at now, right? Which of the following graphs represents the order of reaction with respect to propanone? Hold on, in which year we did the chemistry 2020? What? Which year I did chemistry? 2023? No. Yes. This is my paper. That's my issue. Yeah, this is my paper. No, I remember this question. Alright, so this question wasn't that bad. So which of the following graphs represents the order of reaction with respect to propanone? So propanone, right, when we change propanone, let's say we use experiment 1, experiment 3, these changes, what's gonna happen here?
23.
Yeah. Right, so what's gonna change here? Right? So we're gonna have 0.5 and 0.25 right here. So what's the change? We have to keep iodine constant, right? I forgot. So we're gonna have to use experiment 3 and experiment 4, right? And we're gonna see that this is going to be increasing, right? So if it's what happens here, it doubles. So 0.25 times 2, we're gonna have it doubling, right? Therefore, if we get 5.4 times 2 and we get the 10 point roughly, okay, it's gonna be 10.8 actually, right? But it's gonna be doubling roughly, so it's gonna be our first order reaction here, right? For this now, 19 which of the following statements is correct. Electrons will actually be flowing from what to what? It's from zinc to copper, yeah, right? Reactivity series from zinc to copper, that is fine. Which of the following pairs of acids is conjugate base aligned correctly to hydrogen sulfate and the sulfate? Lovely, that must be the answer, right? C is the best answer here.
Yeah.
Lovely. I remember this question. This is definitely year I did. The gaseous equilibrium, right, of this gas at room temperature and pressure is yellow in color. What will be the observed test? Um, observed in test tubes 1 and 2, the following equilibrium, right? So the following equilibrium, right? Remember, no, this is going to be a endothermic reaction. One is gonna be brown, right? Because the water bath is around 70, right? And then if we increase the temperature, if we increase the atmospheres, right, number of atmospheres, what we're going to get here, right, is a shift of the equilibrium. We're gonna get B, right? So that is that. Remember, if we increase the pressure, we're gonna move to the higher number of moles, right? And if we increase the temperature on an endothermic reaction, we're gonna drive the reaction closer to the reactants, right? So that's what we're gonna have there. For this equation now, right, all we do is basically, all right, what we do for this equation again, how did we get the 29? Right, so the Kc value of that is that. What is the value of the Kc at 25 degrees Celsius for this reaction? Right, what we're basically doing is halving everything, right, in order to get the general equation here. So if the value of the Kc is that, right, then we'll have to look for the new value of the Kc at 25 degrees Celsius with that reaction there, right? So what's gonna happen here? What's gonna happen? How did we get the 29? We have 860 as a value. How do we get 29? Or we get 29? Nobody wants to answer?
So I don't know. So because me personally, I don't know.
Is the 29 the right answer here? If the Kc for the equilibrium is 860, right, here, and then when we half everything, right, what should we get? Is it 29? Is this answer correct? That is my question to you guys.
I remember doing it on previous papers, and yeah.
So what is it that we do?
Sir, if you say we are halving everything, should the answer be C?
I mean, it looks like the answer should be C, just like with the calcium sulfate
Sir,
question where it looks like the answer should be 1.
sir, I would say C2 because
So if we divide 860 by 2, we're going to get 430, right? But is that the right answer? We just half it. Is that all we do? Hello? What is it that we do?
sir, I got 430. I'm not sure how would arrive at 290.
Yes, that's what I'm asking.
At
How do we yeah, how do we arrive at 29? How did this person arrive at 29? That's the question I'm asking, Do we not know? I mean, it's, yeah, you guys said, like, we don't know, we'll get that.
I don't know how they got that.
Yeah, but, like, you said that is the answer, didn't you?
Because I've seen it on multiple people saying the same thing because I just work with it. Honestly, couldn't tell how they work, how you get it.
Alright, so,
I see it 3 times on different sources.
okay, after I'm going to look for an explanation of the work and go through with you guys. Alright. I did the working already, I want you guys to get it. Alright, I'm gonna go through this one, especially this one. Let's go through this. It's on other recordings though. So I'll send the recordings for that. Alright, let's finish up the paper real quick before I go through that. Alright. The value of Kp in the equilibrium here is set as that. What is the value of the Kp if the pressure is changed to 2 atmospheres and the temperature remains the same? If the pressure is changed to 2 atmospheres, that now going to affect the Kp, the temperature affects the Kp, so therefore 50 will remain. It will not affect the Kp. Which of the following metal sulfates would precipitate out of solution if equal volumes of that solution containing the sulfate ion in group 2 metals are mixed? Alright, so what's going to come out? We're going to be looking for the most insoluble of them, which is strontium and barium. The answer is C. Calcium sulfate is way less soluble than the rest of them, right? So looking for the equal amounts of strontium and barium will come out. Alright. Which of the following titration curves is most likely when 25 cubic centimeters of 0.1 moles of sodium hydroxide and 0.1 moles of ethanoic acid is added together? This is the strong base weak acid. So what would the strong base weak acid look like? Would look like this. Lovely. This is the best answer, right? So we'll start with the strong base sodium hydroxide and we'll go to a weak acidic solution so it won't go towards 3 or 1. Lovely. That is that answer there. We'll write this like that. Why this is beginning to look like I me answer the question here? Then pick that paper here. Alright, okay, let's look at this. Probably stop. Alright, so the silver chromates 4, right? So we have that there. Al2CrO 4 is sparingly soluble in water. The unit of solubility KSP is going to be what? So we're just going to look for the units there. Alright, so the units of K should be really simple to come up with. Right, in this case, after you write out the KSP, right, we'll look at the concentrations that we have and then we manipulate our values, right, in order to get our answer, right? So I think for the question, this would be the answer, right? C should be the answer for this question. Because all you need to do is write it out. Something one cancel, right? On the bottom, right? Leaving this at the top. So you guys should be able to do that, right? Joan, not Joan, but John plans to measure the rate of a reaction between calcium carbonate and hydrochloric acid. So we know that carbon dioxide will reproduce. So what is a apparatus that we can use to investigate the rate of reaction? That would be a gas syringe, because a gas being produced. Lovely, busy and so. This paper was never that difficult. The activation energy of a reaction is the energy barrier of the reaction. Lovely. That is the answer there. The next one is a repeat question. We need a smaller solid. We need a greater ionic product and a greater solubility. And a smaller solubility product. C is the answer here. This is a repeat. Oh, I serious question. Alright. Which of the following types of acids and bases would produce such a curve? It must be a strong acid and a strong base. Strongly acidic, then strongly basic. Must be strong acid, then strong base. D is the answer.
Wait, sir, go back.
Okay, let's go up. This question?
Because I think I've seen where Mr. Scott,
Go ahead.
Mr. Scott, no, the screen move. Why am I thinking of it? Hear me? The one about the activation energy.
So the activation energy one? The energy barrier for the reaction, unaffected by temperatures, unaffected by catalyst.
Okay, because the option in the other question says it is affected by only the catalyst. Okay.
Okay. (31) Which of the following four substances A, B, C, and D, right, is an oxide of sulfur, right? So the sulfur oxide is going to be a gas, right? Simple. Well, covalent molecular is going to be a gas, acidic gas. Lovely. 32. Which of the following elements in the third period will have the same oxidation number of all of its known compounds? It's going to be aluminium will have the same oxidation state, right? Generally, right? Which of the following compounds would produce lowest pH? That would be the sulfur trioxide, which forms sulfuric acid. The species donating electron pairs to the central atom. That would be a ligand. Lovely. Alright. Which of the following elements will have the highest degree of paramagnetism? In this case, it will be copper, because cobalt is not here. Copper would be the best answer if it is not cobalt. A piece of clean platinum wire is dipped into a powdered solid, right, and then burned in a Bunsen flame. It will give a brilliant. It will give a flame showing of a brilliant brick red color. This would be calcium. Barium will be green. Sodium will be yellowish orangish. Potassium will be lilac. Alright. Which are the following statements about oxides of oxides of elements in period 3 sodium to chlorine is not true. The oxides react with what to form alkyl? Period 3 oxides are acidic oxides. So that's why it would not be true. They cannot form alkaline solutions in that case. Right? Which of the halogens would oxidize thiosulfate ions to tetrathionate ions, right? Let's look at this. Mm-mm-mm-mm. All of them are more positive than the less positive thionate. Therefore, right, we're gonna have all of them. All of them have a higher EMF value, right? All of them have the advantage to actually create the thionate ions. All right. The green flame here, we know that copper will give a green flame. We know that sodium will be yellowish orangish, calcium will be a brick red, and magnesium would be a brilliant white flame. When concentrated sulfuric acid is added to sodium, well, to solid potassium iodide, the observations are steamy white fumes and a rotten egg smell as sulfide gases are produced. Sulfur gases are produced. Sulfur has a pungent smell. Here we come back to the repeat of this question. The sharp increase from copper to zinc is caused by the filling of the 4s orbital. The only difference between copper and zinc is the 4s orbital. They both have filled 3d orbitals, right? But copper has a half filled 4s, zinc has a full 4s, right? So that's the difference between them there. 42 calcium carbonate decomposes at a lower temperature than that of barium carbonate, right? And what we're looking at here, let me see, calcium oxide, so let's table up. No. And the enthalpy of formation is less negative, no. Let me see, lattice energy of calcium oxide is larger than that of barium oxide. The thermal decomposition though, how does lattice energy fare with thermal decomposition? What would that be? We know the greater the value of lattice energy, the greater the energy required to decompose the thing. So why would calcium carbonate have a greater lattice energy? Oh, the oxide. The oxide has a greater lattice energy. C is the answer. The oxide. Right? There are 8 elements in the third period, sodium to argon. Which of the following elements exists as diatomic molecules? That would be chlorine because it is in group 17. It is a halogen. Right? Then which of the following solutions is best suited to determine the presence of halides in river water? That would be sodium nitrate. We know when the nitrate reacts with the barium, it's going to give up, not the barium, with the bromine, right? It's going to give a specific color, right? A precipitate. You're gonna have a greenish precipitate, then a cream precipitate, then a yellowish precipitate, right? As you go down the group there. Which of the following statement about bromine is correct? Is that a red brown color? Yes. It is denser than chlorine? Yes. It is a gas at room temperature and pressure? It is a volatile liquid, right? Not just a gas. So A is the best answer. And that is that for the 2023 Chemistry Unit 1, Paper 1.